Thanks. All right, I want to enhance one small thing that I think we've already talked about, which is formatted print statements. We talked about those, right? Let me demonstrate if we have not. If I do this something like this, x is equal to 7 divided by 13. But 7 divided by 13. And then I do print x equals, comma, I'm just going to save this one as September 5. So if I run this, what am I going to see? That. Now what if that was supposed to be a dollars and cents value for whatever purpose? Or, anyways, you might want to limit the number of decimal places shown. And you can do that with a formatted print. So that's in section 2.5 of your physical textbook. What you do is this. That's one way to print. Here's another way. Print x equals %.2f, meaning we're printing a floating point value, one that has decimal places, and we want it to have 2 places after the decimal point. And then comma x, except not comma x, I'm sorry, that's a Java C++ thing, %x, modulus x. That doesn't really mean modulus in this case. It just means that, yes sir.
Well, wouldn't it being a float's kind of implied, right? Because you're wanting to go over the 2 decimal places?
It is implied. Let's try the same thing with just a flat out pure integer. What I did is I copied that, and I'm going to say y is equal to 100, and then I'm going to print out y is equal to 0.2f %y. And it works. The 0.2f in this particular language, unlike some others, just means treat it as a floating point number and give myself 2 decimal places. If you did 0.1, it'd only have 1 decimal. If you had 0.10, it'd print it out to 10 digits. So that's formatted printing. Did we talk about this? All right. I'd like to steer y'all towards using that. If you need to have more than one placeholder in here, you do it like this. Print x equals %.3f, y equals %.4f. Now we have 2 placeholders, so we got to put our parameters that we're passing in inside parentheses, like that. Weird syntax. You don't do it that way in Java or C++ or whatever. Kind of idiosyncratic, but there we go. It printed out 4 decimal places there, 3 decimal places there. There is another Python 3 specific way of doing formatted print statements. And I don't see it mentioned in the text, so I'm going to skip it for now. So going to our online textbook. Conditionals. In our physical textbook, it's called decisions. Conditionals are things that evaluate to either true or false. So you can compare 2 values. Looks like there's supposed to be a Oh. Looks like there's supposed to be a window here that should work, and it's not working. So anyways, anything like this, x is not equal to y. That would be true if x is in fact not equal to y. X is greater than y. That would be true if x, the value of x, is greater than y. Now some of these are a little bit strange. I'm going to go to the Python shell here and type in 10 greater than 3. Yeah, that's good. What about 10 greater than quote 3? Error. Because this is an int and this is a string. You can't compare an int to a string, but can you compare two strings? Is Abe greater than Bob? No. Bob is greater than Abe. Z would be, is Zebediah less than Abe? No. Zeb is greater than A because Z is farther along in the alphabet than A. So if you ever need to compare two strings, that's one way to do it. It's not a really good way because is Zeb equal to Zeb? No, those are not equal because it is case sensitive. So since it's case sensitive, if you did this, Abe, come on, Abe is less than Bob. This should be true because A comes before B in the alphabet. But what about Abe less than Bob? That's also true. Alrighty. How about Abe less than capital Bob? False. So, although we would have expected this to be true, it's actually following the Unicode order, the ASCII order, which is where lowercase letters have greater values than uppercase letters, which sounds strange. You'd think the big letter should count for more, but no, lowercase letters. So, are you really going to be doing comparisons like this? Are you going to be doing if Abe less than Bob? No, but you're going to be doing that all the time with numeric values. And x is not y. That's looking real familiar, so I think we already did that. How far did we get through this? If statements. We know what an if statement is. You do your if, followed by a conditional expression, followed by a colon. If you replace the conditional expression just with the word true, capital T, then this would happen all the time. And as you see, as you know, every time you have a colon, you have to tab the next line over. And you can have if else. If expression, do something else, do something else. Does every if statement have to have an else? No. If you either wanted to do something or nothing, you just use if. If you wanted to do something or something else, you use else. Then if you're going to chain them, you can do that. If x is less than y, do something. Else if x is greater than y, do something else. Otherwise, print they're the same. So here we go. This is a really dumb guessing game where they're supposed to type in B. So we ask for their choice. Then if choice is equal to A, bad guess. L if choice is equal to B, good guess. L if choice is equal to C, close but not correct. Anytime you have a series of if-elifs, you should have a terminating else at the bottom just to tidy things up, even if you don't expect it to get there. Because what if the user typed in D? If the user typed in D, none of these things would print out. That may be a problem. Maybe we need to print an error message. Whatever we need to tack on down here in our final else, just think about it, okay? If, elif, even if all it does is print unexpected state or invalid value for choice or something like that. So a nested conditional. A nested conditional is when you put an if inside of another if or inside of an else. That same code we saw up there to check to see if they're equal, you could do like this. If x is equal to y, print x and y are equal. Else, if x is less than y, print x is less than y. Else, print x is greater than y. So yeah, you could do it that way. I don't see a compelling reason not just to use elif, huh? You could use elif there. I don't see why you'd want to do it that way. But there are times when you do need to make decisions based on stuff like that. So let's add some code to our little program, asking for their age. Age is equal to, let's use float. Float of input. What is your age? And then let's get another variable. Grad is equal to input. Did you graduate in the past year? Y/n. Because we want them to type in Y and N specifically. I separated mine into two lines just to get it all on the screen. You don't have to do that. So you could do this. If age is less than 18, you don't have to put the parentheses. That's a holdover from teaching too many C++ and Java classes where it's required. Print, sorry, you must be 18 or over. Else, colon, print, you qualify for the discount. And then, if they're a recent grad, if grad is equal to Y, print 10% discount for recent grads. Else, colon, print 5% discount. Now we could rewrite this, but doing it exactly like this, where it gets this exact same output, would be a little bit more tedious to use if-elifs. If you want to think about how you could do it, you would have to print this message inside of two elif branches. Because you could do if age is less than 18, print sorry, you must be 18. Elif, grad is equal to yes, print you qualify for the discount, 10% discount. Else, you qualify for the discount. Anyways, you could do it, but this is probably a more succinct way of doing it. And quite often, you will see nested ifs. I'm going to type something, but don't do it. If, do something, blah, blah, blah. If, another condition, do blah, blah, blah. You know, that kind of thing. Nested ifs are very, very common. Okay, here's something I don't like doing, is putting the constant, the literal, before the variable. What does this mean? If 0 is less than x.
X is greater than
Greater than or equal to 0. No, you're right. Are you? If
X is positive.
Yeah. But what if x is 0? Is it going to come in here? No. Okay, so it does mean if x is positive. But you saw the way my brain froze on trying to figure it out. What I would have done is if x greater than equals 0. To me, it makes a lot more sense to put the variable on the left side of the equation, the expression, and the constant on the right. Doesn't matter, not in the long run, but you know, my brain choked on it a little bit. Yours might when you were looking at it. But here's a case of if you have two chained cascading ifs like that, you can probably link them up with an and statement. Why is that? This is only going to print x is a positive single digit number if this is true, and if this is true. So you could rewrite this. If whatever and whatever, x is a positive single-digit number. So let's go back to our code here, and we will rewrite some of this to work that way. If age is greater than or equal to 18 and grad is equal to yes, print, like I said, 10% discount. So you can use and to determine if something is within a range, and you can use or to determine if something is outside of a range. So temperature is equal to 65. If the temperature is greater than or equal to 32, and the temperature is less than or equal to 212, print it is a liquid, because it's not boiling and it's not freezing. So here we're using and to determine if a value falls in a range. Or you can check to see if it's not in that range. If temperature is less than 32 or the temperature is greater than 212, that means it's either freezing or boiling, right? So print it is not a liquid. So you use or to determine if a value is outside a range. Is that invariably true? Could I use and to check to see if something falls outside of a range? I could. I could take this statement right here. You don't have to do it, but I'm going to copy that, paste it, and just add the word not here. There. All right. If that's not true, then we would print it is not a liquid. So you could either use not to flip the truthiness of this kind of thing, or you can write it like this. And I recommend steering away from not unless you think it makes it clear. Again, it's kind of one of those backward brain hitches, like if somebody gives you a double negative and you're trying to figure out if they meant it as positive or negative. I can't get no satisfaction. Does that mean that he can get satisfaction? No, that kind of thing. So, I try to avoid nots unless it absolutely makes it clear what I'm trying to do. Alrighty, here we go. Catching exceptions using try and except. What we do here is, you've seen what happens, I bet, if you enter a bad value. We haven't actually tested our code recently, so here we go. Run Python shell. Whoops, that's not what I wanted to do. Run the program. What is my age? I'm 19. Ew, and it blew up. Why did it blow up? Input expected at most 1 arguments. Okay, I totally botched that one. Let me just go fix that. I should not have split the print statement up in that fashion. I'm surprised it gave me a problem, but put it all on one line. Run once again. All right, what is my age? I'm 19. Did I graduate in the past year? No. You do qualify for the discount, 5% discount. It is a liquid. What? We don't know what the liquid is. Whatever. So it's all working, but if I type in bad data, it's going to blow up. What do I mean by that? And you know this. If I type in a word rather than a number when it asks for my age, it's not going to work. What is your age? I am 11-3. There you go. Could not convert string to float. 11-3. Computer doesn't know what 11-3 is. I don't either. So you can make your code handle these kind of problems. Conversion errors and things like that are known as exceptions. There are a lot of different exceptions your program can get into. An exceptional state, an unexpected state. For example, you're writing to a disk drive and then somebody disconnects the disk drive. Or the disk drive becomes full. Or it can't open the file name because the file is locked by another process. Or your internet connection get down. All of those are exceptional states that could cause the program to crash. And so there's a syntax for handling this. What you do, let's put it down here at the bottom again. Although it's going to get tedious at having it ask us more and more questions, but whatever. Input, no. Fav or fave is equal to float, parentheses, input, parentheses. What is your fave number? That's going to crash if they type in anything else. Than a number. So what we need to do is we need to enclose that.
Did you forget the second parenthesis?
I'm missing a parentheses. Thank you. I needed 2 parentheses. And I'm going to remove these 2 parentheses. And as a matter of fact, I'm going to take out the spaces too, because when I tab it over, it would go off the screen. Okay. So what we could test it, but you trust me, right? You ran that, you typed in a bad number, it would croak. So what we're going to do is say, try this, Mr. Computer. And oops, if that doesn't work, I want you to run the code that's in the except block, the exception block. Other languages do something called try catch, which means the same thing. You put the exception handling code in the catch. So if they type in something that's not a number, let's scold them. Print, you didn't type a number. Print, so I'm going to pick one for you. And then let's do fave is equal to whatever. There. That's their favorite number. And now let's print out their favorite number. Your favorite number is, comma, number. Test it both ways. Type in some good input and then type in some bad input. You're right, that should be the word fave. Thank you for saving me from a syntax error. All right, everybody who typed number there, because I did. I had a brain sneeze there. So run the module. What is your age? Well, my age is 20. I'm not going to type that one wrong because we didn't put a try catch on it. We didn't put a try except on it. But I did type a slash on it, which blew it up. All right, great. Let's run it again. Don't do that. All right, what's your age? 20. Did you graduate in the last year? No. What's your fave number? I'm going to type something good to see if it works. I like the number 99. And it says your favorite number is 99. Now I'm going to run it again. What's your age? I'm 17. Did you graduate? Sure. Sorry, you must be 18 or over, but that's not fair. I did graduate. What is your favorite number? I'm going to type in some garbage, right? And it says you didn't type a number, so I'm going to pick one for you. Your favorite numbers. So you get the idea. Try catch you use to handle bad input. What could we do? We could loop and make them enter a good value. You know, they didn't type a number, we're going to force them to type in a number. Because it's just assuming something a good technique. Probably not. You know, like if a program asks you for your birth date and you type in garbage and it said, I couldn't read that, so I'm going to pretend you were born January 1st, 1900. That wouldn't be too cool. So usually you will stick something like this inside of a loop to force them to enter good data. But for something like these conversion programs that we write, how many grams of gold do you have? Well, that's 32 ounces, whatever. It'd be okay just to say, okay, you didn't type in a value, so I'm going to assume 1. Let's go fix this age equals float equals input statement. So scroll up until you get there and do the same thing that we did down underneath. Use a try, and then in your exception block, print out that they typed a bad number and that you're going to assume they're 18 years old. Bad assumption. And then set age equal to. So let me write these instructions right here, just like we did downstairs later in the code. Try, and then in the exception, print bad number, assuming age equals 18, and set age equal to 18. That's what you needed to do. Now, is that the correct syntax? Obviously not. Make it look like you did at the bottom of your code. So how can we do that? Well, I'm just going to stick the word try in front of that statement. Since there's a colon there, I have to indent the next one. Then I'm going to put except colon, and I'm going to print an error message. Print, you did not type a number, a valid number. Print, assuming that your age is 18. This is like you go to a recruiter. They're going to take you. You're 18. Alrighty. And then age is equal to 18. Now run it and try to give them a bad age. What is your age? I'm going to type something bad. Nope, you did not give a valid number, assuming that your age is 18. Okay, so that worked. Is that the best way to do it? Not really. We shouldn't just make assumptions. We should loop until they give us good data. Let's do that down here at the very bottom. Now, we could just do it here. We could just do it here. What we need is a variable that we can loop on. Something like this. Okay, you use check or valid. Valid is equal to false because it's not valid data yet. Then, while valid equals false, colon. There's a better way to, another way you could word that, but we'll go with that. Now we need to tab all this stuff over one layer. Boom, like that. But if we do get them to type in a good age, a valid age, we want to set that variable to true so it can exit the loop. Have we talked about loops yet in this class? Not really. Have you talked about them in earlier classes? Yeah, so I'm going to kind of expect you to have the concept already. Valid is equal to true. So you see what this is doing? While valid is equal to false, it's going to keep repeating over and over. Oh, and by the way, let's delete these last two statements. We're not going to do any assumption. There. So here's what I added. I added that line, I added that line, I added that line, and I took away two statements underneath. Those are my new things here.
Is there anything else below that, with all the nested if and else? Is that all just commented down at this point?
I've left all the rest of it here. Maybe I'm not understanding your question.
I just was asking, I tried running it earlier, and it was asking, because it was going down to yes, because it was asking if you graduated recently.
It's just going to keep running everything.
Yeah, we're just piling code on code at this point, so it's not going to make a lot of sense. But the code that asks if what is your age and then bases a decision on it should still work.
Okay.
So I'm going to run it. I'm going to type in a bad value here. It says you did not type a valid number. I can keep typing in bad numbers until I finally give up and give it a good one. So we are looping until we get valid input. Is that the only kind of input loop you could write? No, but that is certainly a very, very, very good way of doing it. Like that. Why does that work? Because if there's a problem, if the program crashes, it's going to crash on that statement right there. When there's a problem here, it's going to jump right down here immediately and print the error message. It's not going to get an error here, blow up, and then go, oh, I better do this first before I jump down here. As soon as a problem arises, the whistle's blown and it gets thrown into the penalty block down here. It goes into accept immediately. So even if we put a print statement here, don't do this, but print yay, whatever. If you put that there, it would not print yay if we gave it bad input. Instead, it would immediately jump down here. So I hope that's clear. I would like for y'all to write your programs so that they don't blow up if users don't give them good data. There are times when you can't really force people to give you good data. You know, like if you're reading something from a file or whatever, you can't ask them to type in a new date. But if you're writing something with a graphical user, I mean, if you're interacting with the user, then you can try to make sure that they give you good data rather than just crash the program because you didn't. Because they didn't. So short-circuit evaluation of logical expressions. This is a little bit more wonky and computer sciencey than the textbook, physical textbook goes. But this is true in C++ and in Java and in a whole bunch of other languages. What short-circuiting means is if you write something like this, if x, we did have x and y up here, right? No, I use those elsewhere. If age is greater than 100 and grad is equal to yes, colon, print. Wow, you graduated at 100. Incredible. If this part is false, does it even need to check this? If your age is not greater than 100? Because both sides have to be true, right? So if the first one is not true, then there's no reason to check this one. And it optimizes itself so that if the first part is not true of an AND expression, it doesn't keep going. What about if you have an OR in there instead? If age is less than 1, or I don't know what we're going to do here. Or fave is equal to 98. Print. I don't quite know what to say. So, if this is true, do we need to check the next one? We don't have to, because if this is an OR, it means if one side or the other. And I'm sorry, we didn't mention OR yet. Yeah, we did, up here. So AND requires both sides to be true. And so if the left-hand side is false, it doesn't check the rest of it. OR requires only one of them to be true. So as soon as it finds one of them to be true, it doesn't keep checking. Is that really important? Not usually. But you could have some interesting side effects. This could be a function call that returned a Boolean value. And maybe you were expecting that function call to be called every single time it ran through the code. I'm going to write this as though it were a function call. Do not type this because it's going to break the code. And is valid user, like that. Is a, like I said, don't type that, okay? Valid user. You might think that it's going to call is a valid user every single time it runs through this code. But it's not. It's only going to call is a valid user if this first expression, the left-hand side of the AND, is true. Is that going to be a problem? Well, maybe not, but it could be. So if you had to have this called every single time, you could make it the first thing rather than the second thing. Something like that. So that's called short-circuiting. I'm going to undo that change now because that was moronic. Here we go, just because we don't have that function written. Logical expressions can short-circuit, meaning that not all of the expression needs to be evaluated. For AND logic, if the left-hand side is false, then the whole thing is false. No further need to keep going. For OR logic, if the left-hand side is true, then the whole expression is true. No further need to keep going. And like I said, does that usually matter? No. The only time it would matter is if there is a reason to expect that this second part here would always be evaluated. And I can't give you any other examples in this language. I could in C++ or Java. Alrighty, debugging. The traceback Python displays when an error occurs contains a lot of information, but it can be overwhelming. The most useful parts are what kind of error it was and where it occurred, meaning what line number it occurred. Syntax errors are usually easy to find, but there are a few gotchas. White space errors are hard to find because spaces and tabs are invisible. So this looks good. X is equal to 5, y is equal to 6, but it's not because y was indented too far. Or what if you hit tab and on the other one you hit 4 spaces? Is it going to treat them the same? It may not. Okay, we are done with chapter 3 of the online textbook. So what is the body? The body is a sequence of statements. What? Within a compound statement. I don't like that definition. Not digging that. I'm not sure how to reword it though. The body of code is all the code at the same indentation level. This is a body of code. This is a body of code. This is a body of code attached to the if statement. This is a body of code that's attached to the else. This is inside of that, it's a nested body of code that's attached to that if. And this is a nested body of code that's attached to that else. So anytime you have a colon and you tab, you're starting a new body of code. It needs to at least be 1 line, but it could be 1,000 lines long. Okay, so I had the question on one of your homework assignments. I believe it had something that looked like this. If underscore underscore main underscore underscore is equal to, nope, I got that wrong. If underscore underscore name underscore underscore is equal to underscore underscore main, and then it had something like main, something like that. Note, these are 2 underscores, not just 1. If you only put 1 underscore on each side, it's not going to work. We'll talk more later about why or what that's exactly doing. But you got to put 2 underscores on each side of these things if you see this code, if name is equal to main. You're going to have 8 underscores total in the whole expression. Why am I commenting on this? I got several questions over this weekend over it. Because it's hard to read, assignments sometimes. Or it may not look like it makes any difference to have single underscores or double, but it does. All right, one more thing we're going to mention. The book covers it. It's a more computer sciencey thing, so I'm surprised that the online textbook doesn't. It's something called De Morgan's Law. What if you had this expression? If not age is less than 10 and grad equal to yes. And you wanted to rewrite that, print something, whatever, and you wanted to rewrite that to eliminate the parentheses. You can't just do this. You can't just go and take out that parentheses and think it's done. I promise you that logic is no longer the same at all. But you can apply something called De Morgan's Law. You would rewrite it like this. If not age less than 10 or not age equals like that. You have rewritten the expression to get rid of the parentheses. Does that make it easier to read? Well, I don't know. Maybe sometimes. You can also apply De Morgan's Law to an OR expression. If not age equals 3 or age is equal to 4. Print you are not 3 or 4. We could rewrite this to eliminate the parentheses from our expressions. Do it like this. If not, no, I wanted to get rid of the parentheses. If not age is equal to 3 and not age equals 4, print you are not 3 or 4. Okay, I really kind of don't like writing things like if not age less than 10. You know what I'd rather write? If age greater than or equal to 10. I'd really rather not write this expression, if not age equals 10. Copy those two lines and paste them. We're going to rewrite them to make them a little bit clearer, cleaner. Instead of not age less than 10, do if age greater than or equal to 10. Much clearer. And instead of not age equals y, make us say age not equals y. Right? That's a lot clearer, isn't it? Let's do the same thing, and then I'll answer your question. Let's do the same thing with these two. The very bottom two, if not age equals 3 and not age equals 4. It is. I'm so sorry I didn't say what the exclamation mark means. That's not equal to. It's the opposite of equal, equal. So we get to use that again down here. If not age equals 3, I'm going to remove the word not and change that to age not equal to 3. And not age equals 4, I'm going to change that to age not equal to 4. Right? That's easier to read and understand mentally than that. Of the two, I would much rather, personally, read and write that one. Is that important to De Morgan's law? No, but if your expression is looking funny, try to simplify it. See if you can avoid knots altogether. Here, we rewrote this expression right here to avoid knots altogether. And that is a valid use of De Morgan's law. So boiling it down, De Morgan's law changes it like this. If you have, and I'm going to just put this as a comment, not A and B, then you rewrite it as not A or not B. If you have not A or B, then that means not A and not B. You see what's happening? In order to remove the parentheses, we're flipping the word. And becomes or becomes and.
What's the reason why you want to do that?
If you think the logic is easier to follow. When I flipped it, it actually became harder to follow, right? This is actually pretty clear, right? But then I said, okay, I have two layers, you know, I have that and I want to get rid of the parentheses, and so I flipped it to that, and that actually made it harder to read. But then I was able to change it so that, in my mind, by getting rid of not entirely, it's easier to follow. Your mileage may vary. It's just a tool you can use. Do you have to do it? No. Is it ever going to break your code because you didn't apply De Morgan's law to simplify an expression like that? Nah. Now I'm going to veer off, and we're going to talk about something that I'll never ask you about. You can replace, if you're writing logical expressions in English, in math, not in a computer programming language, you can replace the word not with the exclamation mark. You can replace the word or with a plus sign. And you can replace the word and with a times, something like that. If you ever wind up taking a logic course, you'll see this used. So if you have the expression, if A and B or C and D,
Is it or and reversed? And is the plus and or is the multiplication?
very good question. If I'm wrong, I will revise it, but I'm going to show you why I believe that to be right. So if I was going to rewrite this, I would say if A times B plus C times D. I could take the parentheses off. In fact, I'm going to take the word if off. Not strictly necessary. That's how you would express it in logic. And just like in regular math, you could eliminate the asterisks, you know, because if you have 3 times B, you know, you can write it on paper as 3B, right? You can't in a programming language. This is totally not programming language. This is just writing logic in English math expressions, not computer language. But there is a reason why I mentioned it. I mean, why'd you mention that if we can't do it in programming? And that's, I do want you to understand why the asterisk means and a plus sign means or. Say we have 2 variables. You know what, this is getting silly. I should have just thrown this in a notepad rather than putting comments everywhere. I'm going to open a multi-line comment with 3 quotes, close a multi-line comment with 3 quotes. If you want to tack notes on here, great. So anyways, if you have I'm going to call them X and Y. X, Y, and then you have a result, and your expression is supposed to be X and Y, we can make up what's known as a truth table. Okay, if X is false and Y is false, and you have the expression X and Y, are they both true? Not really a trick question. No, they're not both true. So that's false. How about if x is false and y is true? Are they both true? How about if x is true? Why am I using,
Because you said why, I think.
yeah,
You wrote why.
false and true. Okay. If x is true and y is false, are they both true? Finally, if x is true and y is true, are they both true? Yeah, they're both true at this point. You could rewrite this using zeros and ones. I'm just going to copy this, paste it, and replace all the f's with zeros, all the y's with ones, and I'm going to kind of bring it close together. Does this look correct? X, 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. So we could see that we could replace, the word false in all of these with the mathematical word multiply, by multiplying them. And Boolean math is a math in which there are only two possible values, true and false. So, zeros and ones. We only have two states, zeros and non-zeros. We could prove the same thing with ORs, if you care. Guess we may as well. Let's do X or Y, and the result. False, 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 true, true, false, true, true. Alrighty. Now only one or the other side has to be true for the result to be true. Is false or false? Is either side true? No. So that evaluates to false. What about this one? False or true? Is one side or the other true? Yeah. Is one side or the other true? Yep. One side or the other true? Yep. So here you go. If you replace those with zeros and ones, I botched that one. Got a little too fast. Kind of the same deal, right? I mean, your eye naturally goes there and goes, well, that looks a bit funny. But 0 plus 0, false plus false is a false. A false plus a true is a true. A true plus a false is a true, and two trues is a true. So that is why I said that you can replace and with multiply and or with plus if you're handwriting logic. Not in a programming language. I don't know of any other programming language that follows that convention. So the textbook goes on to do some stuff with strings, analyzing strings. This is really good stuff. And we're really close to being run out of time. So we may stop there. Let me look. So remember, you can do this stuff on your own time. You don't have to wait for me to step through it, especially the physical textbook. I don't have PowerPoints for it. I'm not just showing it to you on the screen to read to it. You have to read the textbook yourself. So what are we going to do as far as homework for Chapter 3 is concerned? Chapter 3 tutorials. These are all going to be book assignments. Let's see if they look like. I'm going to have to rewrite them to not refer to page numbers. However, you know, you find that script, you find that script, you find that script, you find that script, and you find that script. You run them, you take screenshots, and you're good. And somebody asked, why do you want screenshots? And well, that makes sure that you got the program working. You didn't have syntax errors, for one thing. And another is you could easily email somebody your program, and then they could run it. And then, I mean, I could send you my solution, and you could upload it to the Dropbox without changing anything except the name up at the top of the program, right? Hope that the professor doesn't notice. But screenshots are much more individualistic, so I can make sure that you're doing your own work. So I will upload that. Then I think that's all I'm going to ask from this batch. We will go for the next one. However, the homework, I may as well go ahead and open it, even though it's not going to be due in a week, just so that you can see it. Let's take a look at it. Payroll assignment. Why are we always doing payroll calculators in these classes? Well, we're going to do another one. You're very familiar with this idea from other programming classes. Write a program that will calculate salary based on the number of hours worked in a week and the hourly wage based on time and a half overtime principle. I really probably don't even need to say this, and I bet you've written this program in other programming classes. But anyways, if you work 40 or fewer hours, you don't get any overtime. If you work more than 40 hours, you get some overtime. And you can set it up with an if expression. If else, something like that. So I'll go ahead and post that. Alrighty, guys. You had your hand up and I ignored you, right? I'm sorry about
That's
that.
all right. The second if not, or the first and second if not statement, you were saying age equal to, age trying to equal a string when age was a number.
You're right. I botched that. The question was, why did I make these strings? Now I can't find it. Did I?
Right there. The second
Or the
if
second.
not.
Right. That's real bad right there. It's not if not age equals y. That's if not grad equals y, and or grad equals y. So I made two mistakes there. I had the word age and I was comparing it to the letter y. Would that work? No. And I'm very sorry. I didn't take that correction as we were going. I had a train of thought and then I forgot to jump off the train to get to you. And I suppose I should actually run this and make sure it works. No syntax errors. Yeah, whatever. There's something down at the very bottom that crashes. That's this stuff about if main. That was not a necessary part of the assignment. Just delete it. That was a comment regarding homework.